Now we'll look at infinite intersections and infinite unions of intervals. To get started with this, let's look at an example. Let's look at the interval 0, 1 over 1, or just 1, and the interval 0, 1/2. Okay, so first the interval 0, 1. So I'm going to write out this interval, or draw this interval here. You got 0 there, so that means we're including 0 in the interval. And you've got 1 here. We're not including 1. So it's all the real numbers between 0 and 1, including 0, not including 1. Okay, so this is 0, 1. Now, zero, 1/2. All right, now let's say this is all the blue, all this blue space here. Let's say all this red space here. Now think about what would you get if you were looking for the union of the blue and the red. Remember, this is or. This is all the x's that are in the blue or in the red. Now, all right, so let's pick, like, say, pick an x here, an x in the red. If you're in the red, are you in the red or the blue? Yes. If you're in the red, are you also in the blue? Yes. If you pick an x here, you're not in the red, but you're still in the blue. So the point here is that because the red is a subset or subinterval, if you like that better, of the blue, that means that the union of the red and the blue is just the blue. And now think of, what do we get when we look at the intersection? The intersection, the stuff that's common to both, is just the red. Because the red, right, let's put in 1/2 here. Oops, not 2, 1/2. If we put in the red here, the red is just that part there, right? So the part that's common to both is just the red. Now with this example in mind, now we can look at the infinite union and intersection. So let's look at first the union. Now this is equal to zero, 1 over 1, union the interval from 0 to 1/2, union the interval from 0 to 1/3, union the interval from 0 to 1/4, and so on. So now let's do a similar thing. I'll draw these out. I'll draw each of these four that I have here. Remember, there's more. There's infinitely many of them, but you'll get the concept, I think, if we just see four of them. And this is the kind of thing that I would suggest you doing when you're trying to figure out things like this. All right, so this first one, I'll do in blue. The second one I'll do in red. This one I'll do in green. This one I'll do in yellow. Okay, so the blue is from 0 to 1 over 1. Okay, let's make that into just a 1. As we all know, 1 over 1 is 1. The next one will go from 0 to a half. The next one goes from 0 to a third. The next one goes from 0 to a fourth. So the blue is all of this. The red is all of this. The green is all of this. And the yellow is all of that. Now, when we're thinking of union, now just look at these two here. This is just like the previous example, right? What is in one or the other or both? Right? Since all of the red is right here, the union of the red and the blue is just the blue. Okay, so now looking at the green and the blue, the union of the green and the blue, the green is all of that, right? And the yellow is all of that. So the union of the blue and the red is just the blue. The union of the blue and the red and the green is just the blue. And the union of the blue, red, green, and yellow is just the blue. So the answer to this one is really just the blue. Now let's make this into intersection. And the same concept applies, but in a different way, right? What is the intersection? What's common to both the red and the blue is the red. Okay, so putting these two together, you just get the red. Okay, so those two together. So just that first intersection gives you just the red. Okay, now the red and the green. What's common to both the red and the green? Just the green, right? So now putting those two together, you just get the green. Oh, okay, so now put the green and the yellow together. What's common to both the green and the yellow is the yellow, right? And it just keeps going on and on and on and on and on like this forever and ever and ever. Now here's where things might get a little peculiar. Let's just look at one interval, or one, we'll look at all the intervals, but all infinitely many intervals, but now we'll just look at one line here. Let's say 1/5 and then 1/6. Because the next one over here, right, the next one right here is 0/5, and then the next one 0/6, and so on, like that. So now we're looking at each of these. So the intersection of the blue with the red was just the red, right? And then the intersection of the red with the green was just the green. And the intersection of the green with the yellow was just the yellow. And so then the intersection of, see, I'm running out of colors here. But the intersection of this with this is just going to be that. Then the intersection of, so the intersection from 0 to a fourth and 0 to a fifth is just a fifth. Is just from 0 to a fifth. Then the intersection of 0 to a fifth and 0 to a sixth is just 0 to a sixth. And it just goes on like that. Right, so what's left over when you do all of these intersections over and over and over again? There's only one number left. The only number that actually is left in there is the number 0. Now, it would be tempting to write the answer as that. But see, that's not correct. Right, because this thing over here on the left-hand side of the equals, this is a set. This is a number. So our type is incorrect. We have a set equal to something that's not a set. So to make this work, we need to say, and that's the correct answer.